Amazon DynamoDB. What is Amazon DynamoDB? 1. Fully managed NoSQL database. Amazon DynamoDB is a NoSQL database service that provides fast and predictable performance. 2. Administrative offload. DynamoDB handles tasks like hardware provisioning, setup, and configuration, freeing you from administrative burdens. 3. Encryption at rest. This feature eliminates the operational burden and complexity involved in protecting sensitive data. 4. Scalable tables. You can scale the throughput capacity of your tables up or down without downtime or performance degradation. 5. Monitoring via AWS Console. The AWS Management Console can be used to monitor resource utilization and performance metrics. Amazon DynamoDB. Additional features. 1. On-demand backup. Allows for long-term retention and archival, meeting regulatory compliance needs. 2. Point-in-time recovery. Enables recovery to any point in time within the last 35 days, protecting tables from accidental writes or deletions. 3. Auto-item deletion. DynamoDB can automatically delete expired items to reduce storage usage and associated costs. Key features of Amazon DynamoDB. 1. NoSQL Workbench, a visual tool that aids developers in designing and visualizing DynamoDB data models, facilitating easier database operations. 2. Global Tables, enables data replication across multiple AWS regions, offering low latency access to data and enhancing application availability. 3. Encryption at rest. DynamoDB ensures the security of stored data by encrypting it at rest, thereby protecting sensitive information. 4. Point-in-time recovery, an automated backup feature that provides continuous backups of data for the past 35 days, allowing users to restore data from any point within that time frame. 5. On-demand capacity mode, offers flexible pricing by charging users only for the read and write requests they make, ideal for workloads with unpredictable traffic patterns. 6. RDQL support, a SQL-compatible query language that facilitates querying and manipulating data in DynamoDB. 7. Integration with AWS services. DynamoDB seamlessly integrates with various AWS services such as Amazon S3, AWS Glue Elastic Views, Amazon Kinesis Data Streams, AWS CloudTrail, and Amazon CloudWatch to extend its functionality and improve overall system performance. Use cases. 1. Scalable web apps. Websites with a lot of users can use DynamoDB to keep up with heavy traffic. 2. Mobile backends. Mobile apps can store and get data quickly from DynamoDB. 3. Serverless web apps. DynamoDB works well with systems where you only use servers when needed. 4. Microservices architecture. For apps built as small parts, DynamoDB can store data for each part. 5. Real-time big data analytics. If you need to look at big amounts of data quickly, DynamoDB can help. 6. Gaming leaderboards. Games can show scores and ranks using DynamoDB. 7. Ad tech platforms. For showing ads to users, DynamoDB can keep track of user data. 8. E-commerce systems. Online shops can store product and user info using DynamoDB. 9. Content management systems, CMS. Websites that manage articles or blogs can use DynamoDB to hold their data. 10. IoT applications. Devices that connect to the internet can send and get data using DynamoDB. High availability and durability in DynamoDB. 1. Data spreading. DynamoDB automatically distributes data and traffic across ample servers to cater to throughput and storage needs. 2. Fast and consistent performance. Regardless of data distribution, DynamoDB ensures consistent and rapid performance. 3. SSD storage. All the data in DynamoDB is stored on solid-state disks, ensuring quick access times. 4. Replication across availability zones. Data is automatically replicated over multiple availability zones within an AWS region. 5. Built-in high availability. This replication strategy ensures that the database is always available, even if one or more zones have issues. 6. Data durability. With automatic replication across zones, data remains secure and intact even in unforeseen circumstances. 7. Global tables, a feature that allows synchronization of DynamoDB tables across multiple AWS regions for wider data availability. Service quota basics. 1. Read capacity unit, RCU. 1 strongly consistent read per second or 2 eventually consistent reads per second for items up to 4 kilobytes. 2. Write capacity unit, WCU, 1 write per second for items up to 1 kilobyte. 3. Table limits, no practical limit on table size, initial quota of 2,500 tables per AWS region, and a limit of 1 megabyte per page for query/scan. 4. Indexes, up to 5 local secondary indexes and a default quota of 20 global secondary indexes per table. Key characteristics of indexes. 1. Local secondary indexes, LSIs, max of 5 LSIs with strong consistency with the base table. 2. Global secondary indexes, GSIs, default quota of 20 per table. 3. Projected secondary index attributes, up to 100 attributes projected into a table's local and global secondary indexes. Partition key information. 1. Partition key length, minimum is 1 byte and maximum is 2048 bytes. 2. Distinct partition key values, no practical limit for tables or secondary indexes. 3. Sort key length, minimum is 1 byte with a max of 1024 bytes, no general limit on distinct sort key values except for tables with secondary indexes. Common data types limits. 1. String, max length constrained by item size of 400 kilobytes. Uses Unicode with UTF-8 binary encoding. 2. Number, up to 38 digits of precision, can be positive, negative, or 0. 3. Binary, length constrained by item size of 400 kilobytes, base 64 encoding required before sending to DynamoDB. Item and attribute limits. 1. Maximum item size, 400 kilobytes, includes both attribute name binary length and attribute value binary lengths. 2. Attribute value constraints, no limit on values in a list, map, or set, but must fit within the 400 kilobyte item size limit. 3. Expression parameters, max length of any expression string is 4 kilobytes. Core components of Amazon DynamoDB. 1. Tables, DynamoDB stores data in tables which are collections of data. An example table could be people for storing personal contact information. 2. Items, a table can contain 0 or more items. These are groups of attributes uniquely identifiable, similar to rows or records in other databases. For instance, in a people table, each item might represent an individual. 3. Attributes, items consist of one or more attributes which are basic data elements. For example, in a people table, attributes could include person ID, last name, and first name. 4. Primary key, when creating a table, a primary key is specified which uniquely identifies each item. DynamoDB supports 2 kinds of primary keys, partition key and partition key with sort key. 5. Secondary indexes, these allow querying the table data using alternate keys. They provide more flexibility in querying data. DynamoDB supports 2 types, global secondary index and local secondary index. Detailed understanding of primary key. 1. Partition key, a simple key composed of one attribute. DynamoDB uses this key's value for an internal hash function to determine the item's storage partition. 2. Partition and sort key, this composite key consists of 2 attributes, the partition key and a sort key. Items with the same partition key are stored together and sorted by the sort key value. 3. Key attributes restrictions, primary key attributes can only be scalar and can be of string, number, or binary types. Non-key attributes don't have such restrictions. Overview of secondary indexes in DynamoDB. 1. Purpose of secondary indexes. Secondary indexes provide an alternate way to query table data besides the primary key, enhancing query flexibility. 2. Global secondary index, an index with a unique partition and sort key, different from the table's primary keys. 3. Local secondary index, this index shares the partition key with the table but has a different sort key. 4. Index quotas, by default, DynamoDB tables have a quota of 20 global secondary indexes and 5 local secondary indexes. DynamoDB Streams Overview. 1. Data modification events. DynamoDB Streams captures events when data is modified in DynamoDB tables. 2. Near real-time and order. The events appear in the stream quickly and in the sequence they happened. 3. Stream record representation. Every event is depicted by a stream record which provides detailed information about the change. Events captured by DynamoDB Streams. 1. New item addition. When a new item is added, the stream captures an image of the full item and all its attributes. 2. Item update. For updated items, the stream records the before and after images of any modified attributes. 3. Item deletion. If an item is deleted, the stream captures the item's entire image before its removal. Stream record details. 1. Table name. Each stream record includes the name of the associated table. 2. Event timestamp. The time when the event occurred is also recorded. 3. Metadata. Additional metadata provides more context about the event. 4. 24-hour lifetime. Stream records exist for 24 hours, after which they're auto-deleted from the stream. DynamoDB API Overview. 1. Control plane operations. Handle creation and management of DynamoDB tables, indexes, streams, and dependent objects. 2. RDQL. A SQL-compatible query language to interact with DynamoDB for executing statements and batch operations. 3. Creating data methods. Procedures such as put item and batch write item which handle the addition of items to tables. 4. Reading data methods. Techniques like getItem, batch getItem, query, and scan to retrieve items from tables. 5. Updating data methods. Processes like update item for modifying item attributes in the table. 6. Deleting data methods. Procedures like delete item and batch write item to remove items from tables. 7. DynamoDB streams operations. Methods to manage and access data modification records in streams, such as list streams and describe stream. 8. Transactions overview. Provide ACID properties to maintain data correctness. Can use either PartyQL or classic CRUD APIs for transactional operations. Detailed control plane operations. 1. Create table. Creates a new table with options to add secondary indexes and enable DynamoDB streams. 2. Describe table. Returns specific information about a table like its primary key schema, throughput settings, and index information. 3. List tables. Gives the names of all tables. 4. Update table. Modifies table settings, index settings, and manages DynamoDB streams. 5. Delete table. Removes a table along with all its dependent objects. RDQL operations for DynamoDB. 1. Execute statement. Reads multiple items or writes/updates a single item in a table by specifying the primary key. 2. Batch execute statement. Performs writing, updating, or reading of multiple items in an efficient manner. 3. Execute transaction. Enables CRUD operations to multiple items across tables with an all-or-nothing result guarantee. Data manipulation in DynamoDB. 1. Creating data. Methods like put item add single items, while batch write item adds multiple items efficiently. 2. Reading data. Various procedures to retrieve items, with options to retrieve specific attributes or apply conditions. 3. Updating data. Modify attributes with update item, offering conditional updates and atomic counters. 4. Deleting data. Remove items either individually or in batches. Data types in DynamoDB. 1. Scalar types. These can represent one value. Types include number, string, binary, boolean, and null. 2. Document types. Can represent complex structures like an AJSON document. Includes list and map. 3. Set types. Represents multiple scalar values. Types are string set, number set, and binary set. 4. Primary key specification. When creating a table/index, specify primary key attributes names and data types. They must be string, number, or binary. 5. NoSQL and schemaless nature. Unlike relational databases where you define columns and data types, DynamoDB only requires primary key attributes, making it schemaless. Read consistency in Amazon DynamoDB. 1. DynamoDB read options. DynamoDB supports reading from tables, local secondary indexes, LSIs, global secondary indexes, GSIs, and streams. Tables and LSIs offer 2 read consistency options, whereas GSIs and streams are always eventually consistent. 2. Eventual versus strong consistency. By default, DynamoDB read operations are eventually consistent. This means that the reads might not reflect the most recent writes. Strongly consistent reads, however, will reflect all successful writes. This option is available only for tables and LSIs. 3. Durability and isolation. Once a write to a DynamoDB table is successful and returns an HTTP 200 response, it's guaranteed that the data has been stored. Reads will always return these committed values, ensuring read committed isolation. 4. Global tables read consistency. Global tables enable replication across multiple AWS regions. Changes to any item in any replica table are replicated across all replicas, typically within a second, maintaining eventual consistency. Eventually consistent reads. 1. Default read consistency. Eventually consistent reads may not reflect the outcome of a recently completed write. If the read is repeated after a short time, it should eventually show the latest item. 2. Supported operations. This consistency model is the default for all read operations on tables, LSIs, GSIs, and DynamoDB streams. 3. Cost. Eventually consistent reads cost half as much as strongly consistent reads. Strongly consistent reads in DynamoDB. 1. Supported operations. Operations like getItem, query, and scan can utilize strongly consistent reads. 2. Read parameter. Using the consistent read parameter set to true ensures the most up-to-date data is returned, accounting for all successful prior writes. 3. Consistency on GSIs and streams. Strong consistency isn't supported when reading from a GSI or DynamoDB stream. Global tables and their read consistency. 1. Purpose of global tables. DynamoDB global tables support multi-active and multi-region replication, catering to distributed applications. 2. Replication. Changes made to any item in a replica table are replicated across all other replicas, typically within a second. 3. Read consistency model. All replicas within a global table maintain eventual consistency. Amazon DynamoDB read/write capacity modes. 1. On-demand mode. DynamoDB On-Demand is a flexible billing option that adjusts to the level of traffic without capacity planning. This mode has pay-per-request pricing, and tables using it offer the same latency and security features as DynamoDB. 2. Provision mode. This is the default mode and is eligible for free tier usage. You specify the number of reads and writes per second, and you can adjust the table's provision capacity based on traffic changes. It provides cost predictability by allowing users to forecast capacity requirements. 3. Read/write capacity mode significance. It determines the charging method for read and write throughput and how to manage capacity. You can either set it while creating a table or change it later. 4. Secondary indexes relation. Secondary indexes will inherit the read/write capacity mode from the primary table. On-demand mode features. 1. Thousands of requests per second. On-demand mode can handle a high volume of requests seamlessly. 2. No need for capacity planning. The mode automatically adjusts capacity based on demand. 3. Pay only for what you use. This flexible billing option ensures users pay for their actual usage. 4. Single-digit millisecond latency. Despite fluctuating workloads, DynamoDB promises low latency. 5. Compatible with existing DynamoDB APIs, users can switch to on-demand mode without changing any code in their applications. When to choose on-demand mode. 1. New tables with uncertain workloads. If you're creating new tables and unsure about the expected traffic, on-demand can adjust automatically. 2. Unpredictable application traffic. For applications with varying traffic, on-demand mode can handle the spikes and troughs efficiently. 3. Preference for pay-per-use billing. If you're inclined towards paying only for your actual usage rather than pre-planned capacities, on-demand mode is suitable. Features of provision mode. 1. Set reads and writes per second. Specify the expected read and write throughput based on your application's needs. 2. Auto-scaling adjustment. Provision mode allows for automatic adjustments in capacity in response to traffic variations. 3. Cost predictability. By forecasting capacity needs, users can better predict their costs. 4. Predictable application traffic. Provision mode is beneficial for applications with consistent traffic patterns. 5. Gradual traffic ramps. If your application sees a gradual increase in traffic, provision mode can be a good fit. 6. Capacity forecasting for cost control. By anticipating capacity requirements, users can better manage their costs. 1. Each item in the table has a unique identifier, or primary key, that distinguishes the item from all of the others in the table. In the people table, the primary key consists of one attribute, person ID. 2. Other than the primary key, the people table is schemaless, which means that neither the attributes nor their data types need to be defined beforehand. Each item can have its own distinct attributes. 3. Most of the attributes are scalar. which means that they can have only one value. Strings and numbers are common examples of scalars. 4. Some of the items have a nested attribute, address. DynamoDB supports nested attributes up to 32 levels deep. In this example, I am creating a DynamoDB table, which has table name music. Artist and song title has data type string. Artist is the partition key denoted by key type equals hash. Song title is the sort key. 1. Write item to a table. 2. Read item from a table. 3. Delete item from a table. 4. Query a table. 5. Delete a table. 6. List table names. Thanks for watching.